This is homework set 25. This is our introduction to functions and relations. Question 1, we've got a relation, and I want to know what is the domain, what's the range, and is this relation a function? Well, first of all, the domain is the set of all first components. So these are our input values. So the domain here is 4, 5, 6, and 9, and it is this 6, right, not this 6, it's this 6 right here. And the range, that's the second components. That's the collection, the set of second components. How about 8, 2, 6, and 5? So put those in. So 8, 2, 6, and 5. Now, is it a function? Just run a check here. Where does 4 go? Does 4 go only, 4 goes to 8. Does it go anywhere else? All right, 4 goes only to 8, nowhere else. 5 goes only to 2, nowhere else. 6 goes only to 6, nowhere else. 9 goes to 5, nowhere else. So every input goes to exactly one output. And you can see just by looking at this, as you look at these ordered pairs, all you have to do is look at the first component. If the first component appears only once, it's going to be a function. All right, so I'm going to say, is it a function? Yes. Question 2, much the same as question 1. First of all, what is the domain? Now, the domain is the collection of first elements. All right, so what are we going to look at here? 6, 4, 3, and 7. All right, let's list those. 6, 4, 3, and 7. First components. The range, that's the collection, the set of second components. How about 8, that 4, and that 3? All right, so let's go with 8, 4, 4. Now, do I need those 2 4s? No, I don't need 2 4s. 4 shows up, so I only need it once. So I get 8. I've got that 4 and that 4. So 4 is in the collection. So I need to write it only once. And then I have the 3 at the end. Now, is it a function? I'm going to say yes, because every one of those first elements goes to exactly 1 second. Where's the 6 go? The 6 goes only to 8. Nowhere else, right? There's no more 6s. Where does 4 go? 4 goes to 4, and that's all. Where does 3 go? Well, 3 happens to go to 4, but that's okay. 2 inputs can go to the same output. So 4 goes only to 4, 3 goes only to 4. So second components, we can repeat. First components, we can't. Question 3, is this relationship, what's the domain, what's the range, and is it a function? So here's the domain. Domain of first elements. What do we have? We have a 3, a 7. Now 7 appears again. I only need to write it once, and an 8. So what numbers do we have in the domain? What numbers can we use as inputs? 3. Oh, let me get it to right here. 3. We can use 7, and we can use 8. And the range. If we put those numbers in, what do we get back out? That's the second components. We'll get out a 2, a 6, a 1, and a 9. So we'll get out a 2, a 6, a 1, and a 9. Now, is it a function? So let's check. Does every input go to exactly one output? I see a problem here. You see that 7? It goes to 6, but then it goes to 1 also. So it's like if it was time, 7 would go to 6, then later it goes to 1. So this is not a function. So I'm going to claim no. Homework set 4. What's the domain here? What are the first elements? I see a D, an E, an F, and a K, and the domain, that's the domain. The range are the collection of second elements. I see a 5, a 2, a 1, and a 4, and is it a function? Yeah, look at the domain. Do you see any repeated elements? No. So I'm going to say yes, this is a function. 5, D goes only to 5, E goes only to 2, F goes only to 1, K goes only to 4. Question 5, what do you think? Is this relation a function? Let's look at the domain. The domain is the collection of first elements. G, all the first elements are G. So the domain here is G. The range, second elements, we've got a 1, a 9, a 4, and a 3. Is it a function? I'm going to say no. And I'm saying no because if I input a G, I get a 1. If I input a G, I can get a 9 or a 4 or a 3. So one input goes to more than one output. So if I put in a G, that could go to a 1, it could go to a 9, it could go to a 4, it could go to a 3. So because it goes to more than one output, it is not a function. Well, we've got this parabola now, y equals x squared plus 4. It's graphed right here. So we're going to use the graph to find the domain and the range and then determine if it's a function or not. Well, first of all, it is a function because it passes the vertical line test. If you pass a vertical line anywhere, well, almost a vertical line, it intercepts the curve only once. So it is a function. Now, what's the domain? Well, the domain, this is a collection of all the x values. Now, those are the horizontals. So the horizontals, follow this out here. If I go to the left, it just keeps going, all the way to infinity. So I could put in any number here. If I put in any number here, I can follow it up and it's going to intercept the graph. Same thing over here. No matter what I choose, if I go up high enough, it will hit the graph. So the domain is the set of all real numbers. And we're going to write that like this. That we can go from negative infinity to infinity. And the range, well, what about the range? Now the range, these are the output values that the function will assume. So what do we have here? So look at the output values. Now these are the verticals. There's nothing down here, right? If I go over here, it never intercepts the graph. But as soon as I get to 4 and above, we start getting output values. So I'm going to claim that I'm going to put a square bracket around 4 because I think 4 is included here. And then it goes all the way to infinity. So infinities are not included. So I'll put a open parentheses. And is it a function? Yeah, we determined that. It passes the vertical line test. Question 7, let's read it. Says the chart shows the estimated number of camera phones and non-camera phones sold in 2004 to 2010. Now, using the chart, list all the values of the domain, the range, and the total phone sales. All right, so what's the domain? These are the input values. Now, the input values, these are along the horizontal. So what do we have? We got 2004, 2005, 2006, and so on. So let's write that. 2004, 2005, 2006, 2007, 2008, 2009, and 2010. And the range, these are the output values. Now the output values, these are coming from the verticals. All right, these are the verticals. So in 2004, what did we have? There was 680, 730. All right, so let's put those numbers in. So it's going to be 680, 730, 800, 900, 920, 990, and 1030. Well, let's read through this. It says the length of time, capital T, the length of time in seconds it takes a pendulum of a clock to swing through one complete cycle is given by this formula right here. All right, so we have this formula. The time, says, depends on the length of the pendulum. So imagine this pendulum here goes through one complete cycle. Now, if it's a longer pendulum, it's probably going to take longer to go through that complete cycle. So depending on the length, the time it takes to go through a complete cycle depends on the length. Now, here's what we have. L is the length in feet of the pendulum, and pi, okay, we're going to approximate pi with 22/7. So how long, right, how long? That's L, right? So this is L. How long must the pendulum be to complete one cycle of 2 seconds? Now that 2 seconds, that's time. So here's time, and here's the L. All right, so let's put the numbers in and see what we get. So T is 2, so we'll get 2 is equal to 2 pi. well, actually, instead of pi, they're telling us to write 22/7 square root of L, which we're trying to get, over 32. Now, first of all, I think I'll just multiply here. So I'll get 2 is equal to 44/7 square root of L over 32. And now I've got a fraction. I'm going to multiply both sides by 7. So here's what I'm going to do. 7 times 2, that's going to be 7 times 44/7 square root of L over 32. So we will get 14 is equal to, those 7's cancel, we'll get 44 square root of L over 32. Now, I think what I'm going to do here is divide by that 44. So I'll get 14 over 44 is equal to the square root of L over 32. And now I'm going to eliminate this radical, this square root, by squaring both sides. So I'm going to get this. 14 over 44 squared is equal to the quantity square root of L over 32 squared. Now you probably need your calculator for this. Go ahead and square 14. It's 196. Square 44 is 1936. Okay, so I squared the left side. When I square the right side, when I square square root, the radical comes off and I get L over 32. Now one more step, let's multiply by 32. So it's going to look like this. 32 times 196 over 1936, that's equal to L. And when I multiply the 32 and the 196, right, this is going to be 32 times 196 over 1936. Now I'm going to see if I can reduce this a little bit here. This is equal to L. Okay, this looks like a monster to reduce. So what I'm going to do first of all is, I think I'm going to try 4. So on your calculator, 4 will go into 32 8 times. Now on your calculator, 4 will go into 1936 484 times. Now I can divide by 4 again, so I'm going to do it again. 4 into 8 will go twice. Now 4 into 484 goes 121. Okay, and now I've got this. Here's where I'm at. 196. Oh, I've got a 2 out here. Don't forget that 2. There's so many lines here. 2 times 196 all over 121. That's equal to L. And 2 times, okay, 2 will not divide into that 121. So go ahead and do 2 times 196. So L turns out to be 392 over 121. Okay, that's the exact answer. So the question is this, right up here. How long? Well, it takes this many seconds, right? That many seconds. Now that's a little awkward. I mean, nobody's going to say it takes that many seconds. So if you want to reduce it to a fraction, go ahead and make the division. And if I was going to make that division, I'd go back up here, and this is what I'd put on my calculator. I'd put 32 times 196 divided by 1936, and that comes out to this, 3.24, say. It's about 3.24 seconds. Now, I don't think the homework's going to take that because it's probably looking for a fraction. And that ends our first part of homework set 25.